Engineering Department from Dr. Bapuji Saunke Institute of Engineering and Technology organized the Faculty Development Program on Solar Lab Software Simulation. Just before starting the session, I welcome our Institute Director, Mr. B. Sir. Good afternoon, sir, and welcome. Also, I welcome our Institute Principal, Dr. Sapate, sir. Good afternoon, sir. Both the persons always encourage and motivate us. I heartily welcome all the participants. Before start the session, I just request to our principal, Dr. Sapate, sir, say a few words, sir, about the FDP. Please, sir.
Thank you. Good afternoon, all the participants. On behalf of Dr. Bapuji Saunke Institute of Engineering and Technology, welcome all the participants to this session. Sir, I request all the participants to please activate. Hello. Am I audible now?
Sir, some interruption in your voice, sir.
Okay. So I welcome all the participants and request all of you to participate actively and interact with the resource person. That's it. Thank you. Please go ahead.
Oh, okay, sir. Thank you. So I just move on. I just introduce our today's FDP session leader. So I just move on to introduce our today's resource speaker, Professor Manthan. I just introduce him, the technical officer working at Hoshang Patel Technology Center and specializing in solar power utilization and solar power grid generation unit. Professor Manthan has basically focused on technical and operational strategy documents to ensure the various systems, and also he works on various solar projects such as 200 kilowatt rooftop installation at Garga Institute of Technology. Welcome, sir. I warmly welcome behalf of our institute, Dr. Bapuji Saunke Institute of Engineering and Technology. I just request you, sir, please start your session.
Okay, thank you. Good evening to all. Am I audible? Okay, is the sound clear and everything? Yes. So basically, my name is Manthan Rane. I am working as a technical officer in Hoshang Patel Tech Center. Basically, I have completed my degree almost 1.5 years ago, and joined the solar manufacturing. We have our technical center in Garda Institute of Technology, where we manufacture solar panels. We manufacture solar street lights. So electronics is somewhat of a part. And this is a Section 8 company. So we donate all these equipments, all these solar technology, solar knowledge to a lot of people surrounding. So that is what continuously. Okay. While moving to solar, while working as in production, we had a complete manual line of production. We had some of electrical students visiting us almost, I guess, last month. Right. So we have a manual production line where we handle solar cells, we test them, we cut them according to various sizes, we connect them in series, parallel. We have multiple wattages of solar panels. We make a sandwich of them containing all its stuff. We laminate them properly so that a panel generates electricity for 25 years, and then we have its all physical we deal with its physical properties. It is and also a solar panel, what you see is what it has to be after 25 years. So all these things related to soldering, related to lamination, related to machineries, I have completed my degree almost as a mechanical engineer, working with machines, but solar is a part where all our branches come together. We have we need to have the knowledge of civil, we need to have the knowledge of electrical, we need to have this knowledge of MPPTs like electronics, and also we need knowledge of architecture and design. While talking with manufacturing point of view, as a mechanical engineer, to have a lot more hands-on with production, a lot more hands-on with machines working like hydraulic valves. While lamination process, you have to deal with temperature, vacuum pressure, then also how to keep the machine heated up. So different types of oils and everything. So this is part for manufacturing section. Then with the electrical system, when you keep in mind a solar system, there are two sides. One side you have DC system through which a solar panel generates the DC power, right? So you have DC system, and on the other hand you have AC systems. AC system, after inverter you will have all the AC supply running off to the grid. So you need to have these electrical systems, electrical knowledge for all of this. Also civil related, while you have to assemble a solar structure on any of the roof, so you need to keep an eye on the solar angle. You need to design your system in such a way that it must be shadow free. Also you have to design in such a way that there must be all the heat access, and there must be a lot more solar accessibility. So solar, you have to get thorough knowledge of all the other streams which you are using so far. So that's all about. Let's now move towards the solar lab software. I'm sharing my screen. Is my screen visible to all? Yes, is it visible? Yes. So this time what we'll do, for this first session, we will just have an introductory part of the Solar Lab software. This is basically a Archive 360, now, which is the design point of view. The Solar Labs is the marketing point of view for this website. If you see, this is a Chrome-based software through which you can design, analyze, permit, and manage all your solar plants. Okay, you can have a multiple thorough analysis. You can design a solar plant in all ways. You can try all the permutation combinations for your solar plant. And this software helps us to gain thorough knowledge, and also to get, also it helps us to see the optimal generation, optimal losses, optimal all the things. You can try various sorts of solar panels, you can try various types of inverters, you can try various types of wires, you can try various types of solar angles, you can try various types of sets of solar panels, and see if your space, if your solar space is easily accessible. Rather, your solar is an investment point of view, the investment is quite high. So you can check if the solar investment, whatever you will be investing in the initial period, will be generating you the ample amount of solar light, ample amount of generation, ample amount of let's say accessibility, so that you will be generating a lot more power. So basically, first I'll clear what all these three types of solar systems are. Normally, a lot more houses you will see on-grid solar system. Does anyone of you know more about solar systems, or you know basics of all these solar systems? Anyone of you? Or you have installed solar systems in your home? Yes. Okay, so let me tell you, there are basically three types of solar systems. So first type you see here is on-grid solar system, where you have solar panels, you have your inverter, and this inverter generates DC supply to AC supply, and it connects the grid. This is our grid. Like say we have MSCDCL, right, Mahavitaran. So it is connected to grid. In simple format, if I tell, you will generate DC supply through solar panels. It will be connected to inverter. It will invert from DC to AC. Then this supply will be connected to a net meter. Net meter is a bi-directional meter which has CTs on both the sides. On the load side also you will have current testers. On the grid side also you will have current testers. So if you are generating 10 units, then and you are consuming 2 units, so 10 and 2 units will be consumed and 8 units will be exported. You see both the sides arrows. So this is a bi-directional meter. So bi-directional means you are completely connected with grid. So disadvantage in these systems is when MSCDCL power fails, when MSCDCL shuts down its power, your inverter automatically stops. It has to stop. Okay, this is a safety point of view. So this is a bigger disadvantage. Let's say in rainy season when we have almost power losses for 2 to 3 hours. So at that time what happens, you will have solar excess, you will have solar intensity, but you can't be using your power in your load section. So this is what this on-grid system does. The thing is, you will generate, you will use it, or else the excess power will be net exported. And in the evening time, you will import the power from grid through net meter. So while billing section, you will have your net import, you will have your net export, and you will have your total consumption. So when you will calculate, you will have whatever the balance amount, balance units. If you will be consuming, if you will be consuming more, or else you will have an balance generation which you can keep for banking, or which you can use them while low solar excess, let's say while rainy seasons. The another system which we have in solar is off-grid system. There is no grid connection in off-grid system. You will have your solar panels, you will have your inverter, you will have your load. The thing is, off-grid you will not have the grid access. So what you will do, you will use a battery bank. It can be lead acid, it can be lithium ion, it can be lithium phosphate, it can be lithium magnesium. Whatever battery type you need, you can use it. You will generate solar intensity, solar light. You will invert it and use it for your load. And also in the evening section, you will use the electricity from your battery. So the thing is, in the evening section, you have to calculate the load, whatever load is there, whatever electrical appliances you will be using in your home for the whole night period. You will calculate its total energy consumption, and or according to its total energy consumption, you will set up the sets of batteries for the respected inverter. So this is what an off-grid system works. Okay, so then you have is hybrid system. In hybrid system, you will have your batteries, you will have a net meter, you will have an inverter, and you will import, you will generate, you will export, you will store in your batteries, and also you will use it in your home. So this is what a hybrid system does. Basically, you will generate 10 units, you will store 3 units for your night consumption, you will use 2 units for your daily, let's say household work, and remaining power will be exported to the grid. So whenever you will have less solar generation, you will have the power from grid, and you will use it to the load side. So this is an hybrid system. So with respect to all the system, cost differs. There are specific inverters designed for on-grid system. There are specific inverters which are designed for off-grid system, and there are specific inverters designed for hybrid system. Keeping this all these three systems in mind, there is also an advantage or upgraded version in this on-grid system, which is called as net zero export. So this is a system, this is a function installed in an inverter which will have a zero export function. What is zero export function? What it will do? So it will calculate your daytime, let's say consumption at particular microsecond. Okay, am I clear? At particular microsecond, it will calculate whatever current is being flown to your home, and it will convert the same amount of energy from solar panels. and it will at most try not to export the power to grid in an on-grid system. Okay, so this is what today the daytime this has been upgraded into inverters, so that like let's say companies, let's say schools, a daytime running offices. So what they can do, they can utilize utmost the zero export device function in an inverters and almost make it net zero, make import net zero. So it is very beneficial for this grid type of system. Okay, the thing and the disadvantage with working with grid is grid not only pays us whatever we use, they impose taxes, they impose fuel charges, they impose wheeling charges, they impose several other charges in several other ways. So whatever we consume, they generate it for almost 1 unit and they sell it for almost 4 to 5 units. So which reflects into our, let's say, ROI, return on investment. So whatever investment you will do, whatever generation you will do, so if you connect it with grid, whatever grid will also take its own share. So it reflects in all our total calculations. Okay, so basically this is the basics of all these three systems, and whatever current upgradation, let's say zero export function is which is going on grid systems. Is up to this thing everything is clear, or any doubts towards your side you can ask? Yes, yes, yes. On grid system, can you speak again, please? Yes, in on grid system, yes. Okay. Any other thing? Okay, all these things are clear. So, if you are heading towards installation of solar systems, then your system design must start in such a way, while looking at your building, while looking at wherever you are going to install, it must be solar accessible. There must be no trees going off, so that as any shadow will be there. While designing a solar system for any of the equipment, any of the home, let's say, so first we will start with what is the current consumption of a home, let's say of an industry or any commercial building. Okay, so first thing you will know is its consumption, monthly consumption you can track and have an average for almost 5 to 6 months. So when you will know what is the consumption, then you can decide whatever solar system install. Let's say if you are consuming almost 10 units per month, then you can have a day per day calculation, and on per day calculation basis you will have your solar system, let's say 1 kilowatt, 2 kilowatt. Okay, you will be knowing 1 kilowatt systems, 2 kilowatt, 3 kilowatt, and then 10 kilowatt, 15 kilowatt, 50, 100, 200. These are mega projects. Let's say in megawatt when we go, then it becomes megawatt project. So while designing 1 kilowatt or 2 kilowatt system, there is a thumb rule in solar. So when you install a 1 kilowatt solar system, it generates minimum of 3 units per day. Okay, 3 units of solar generation it does. So you have to calculate your per day consumption and multiply and divide it with 3. So you will have a kilowatt solar system what is required for an industrial or commercial purpose. Right. So when you know whatever solar system you need, then what you have to do is have a proper on-grid system. Then you will know. Then you will decide you will need a grid on-grid system, off-grid system, or hybrid system. Okay. So if you are going on for grid system, then you will have an inverter. You will specify which inverter you will be using. Inverter, what it does, it converts a DC system to a DC current to AC current. Then based on the inverter, it has its own connections. It has its own connection for DC wires. So this DC wires you will have, it's a single MPPT and double MPPT type of thing. Then you see whatever you will have a data sheet of inverter where it clearly indicates what is the minimum input voltage and what is minimum input current. That way, same as you will have its maximum input current and maximum voltage. In between that, you will have you must of let's say voltage DC system. You have to connect the amount of solar panels in series so that you get a 70% of voltage, rated voltage, let's say DC, and current based on series, and then you will have what you can see, you can connect it to inverter. This is the DC side. From DC side, when taking a supply to AC side, you will have you will see output voltage and what is output current. Based on output current, you will select its wire. You will have an AC-DB box connected in between. AC-DB box is an AC distribution box. So it has all the safety features which are already inbuilt in an inverter, but still our grid supplier needs them on the separate basis. You will have SPDs, you will have earth protection relays, then all the required safety features on separately installed in an ACDB, and that supply will directly go to the grid and your load side. So you'll have to keep in mind the solar panels you will need. Basically, if you need a solar system for 3 kilowatt, then you will have you must need 3 kilowatt solar panels. Let's say if your 100-watt panels, so 2 panels will together come to 1 kilowatt, and 6 panels will come to 6 panels will come to 1 kilowatt. Okay, 3 kilowatt. So this system will be will consist of 6 panels. You will connect all of them in a series and connect it to inverter. So it has its own MC4 connector. Our electrical system also need a DC-DB box, DC distribution box, which has simple fuses installed in it, and it connects to an inverter. So this is simple steps while connecting an off-grid system. On-grid system, while connecting off-grid system, you have to calculate the battery backup, whatever you need for night usage, and then you can install it to connect it to inverter. The same things you have to keep in mind is the rated voltage of batteries and rated current of batteries. Whatever it will be imported, right? Same as in hybrid system, whatever will be the battery, whatever will be the net meter, and hybrid is an cost-effective system. But hybrid gives you full independence to be completely off grid. If you increase the battery backup, you will generate and you will store it into batteries and have minimal import from grid. Okay. Any doubts again from your side? Okay. So now let us move to our software. So this is an Archive 360. You can also call it as Solar Labs. So this is the dashboard for solar system. So total number of projects for an time being we have this much. You can create a new project. You will have your Google location where you need to do it. So let's say Mumbai. Okay. So where you will be having clear notifications, clear installation, and we can have any of you have to trace the location of whichever building you need to have the solar access. Okay, so let's say I'm selecting this type of building. So you see this building has even almost rectangular shape, and also it has this access, roof access, right? So you have to select it, you have to name the project, you have to give the client's name, you have to give its mobile number, you have to give its email ID. Also, it is residential or commercial, you have to select. Next thing is the project size. It will be, if it is less than 25 kilowatt, which is a small project, and medium project will be up to 200 kilowatt. So on this software, you have a maximum a 200 kilowatt project where you can install and where you can design and have all the types of things. And you can, when you click on create project, you will have a project created for your basic steps. Okay, so whatever I have told is for 200 kilowatt, right? So this is the project which we have created for our Garda Institute of Technology. So this is basically, these are three buildings. This is A wing, this is B wing, and this is C wing. Okay, you can have all this required data. You can have, you can add all the project documents. Project documents has its own affidavits, it has its own SLDs, it has its own electrical bills, and you can track your electricity consumption by net metering, gross metering, net billing. You can add a lot more data. If your system is based on zero export, then you have to select zero export, and you have to place the price at what kilowatt you are selling, at what you are, at what rate you will be selling the power, for power to the utility, or for power to the grid. Then electricity bill, you know, for heavy consumptions, let's say for heavy three-phase supplies or industrial supplies, there is a contract demand. There is a sanction load which you have to sanction from MSCDCL. So it is approximately calculated, and a sanction is taken. In case of our Garda Institute of Technology, we have 642 kilowatt of sanction load, and contract the demand, whatever we have done, is up to solar limit. So for solar limit, we have reduced our contract demand to 200 kilowatt. So which has then when you have a contract demand for 200 kilowatt, in an electricity bill, you have to pay the contract demand charges, which has up to now, it has become up to 75% at a rate of 500 rupees per contract demand. So 500 into 75%, whatever amount it is, so it becomes a net contract demand charges or basic amount which we will have to pay to MSCDCL grid. So this is an on-grid system directly connected to the grid. Based on all this system, we also have to pay for wheeling charges. We also have to pay for electricity duty. We also have to pay for fuel charges and various charges, all other charges. Also, you can have in software, you can have monthly profile, whatever generation will be happening in your solar plant. Your daily profile, you can have the solar generation for all these things. You can upgrade and design. So this is what a complete design for our college looks like. We have almost 670 panels installed on our total roof side. Okay, so this is our college entrance this way. Then you have, this is A wing, this is B wing, and this is C wing. So this totally contributes to almost 240 kilowatt. We have upgraded it to 40 kilowatt later, but here you will see is up to 195 kilowatt on DC side, and AC side you will have 200 kilowatt installed. Okay, in this side you will have total summary of solar plant. So we have a separate inverter installed for our separate wing this side, and we have a separate inverter installed here for these two wings totally. While designing a solar system, you have to design solar panels in such a way that it has to be optimum in space. So it has to use all the available space and all the each of the roof side. Okay, so which will contribute in less power generation, which will have less losses. Okay, and then next thing is you have to because this length almost, if you see, is almost in 35 to 40 meters. So 42 meters length you have to design in such a way that you have to use less wires. In DC supply, what you do, whatever generation you do, the DC supply, if you need to take it at distance, then you will have voltage drop because it doesn't have frequency, right? So you have to design your system in such a way that you have to place the inverter as close as possible to all the solar strings, and you can take AC supply almost up to 100 meters to 200 meters. There is no need at infinite distance. You will have less losses. But DC supply, you have to design the plant in such a way that you have to place the inverters at such height. I mean, this togetherly contribute to one single table. So these two terminals, when we connect this 18 panels in series, a single wire will be running together and directly be connected to the inverter. So you have to design in such a way that you will use less wire and to the less distance. Okay. Then also while upgrading to 40 kilowatt, we have installed some panels on this side, and also we have installed some panels on the other side and this side. If you see the direction, you will see north side upside and south side down. So this is east and this is west. So sun rises from this side. We have maximum generation at daytime over this side, and the roof, which is solar applicable roof, is north side up, south side down. So all the north facing roofs we have selected, and we have installed solar panels on other side. So this total window represents a design studio. So here you can try all these designs. You have a home summary where you can name your project. You can have several designs. The latitude, longitude of the project you can see. DC side, whatever it is installed, you can see. AC side, whatever is installed, you can see. You have a DC to AC ratio. You have the module quantity. It is 5 panels. Each panel is of almost 315 watt, 315 watt. So you see this 585 panels, and then you have inverter quantity and also the AC rating, optimum AC rating. So when you calculate generation, so a generation report is calculated, and you can see the optimum generation what you will have. You will have almost 273 megawatt of power annually, and a daily performance ratio, if you see, is 73%. Why it is 73%? While manufacturing a solar panel, there is a term called field factor. Field factor is a term which represents the intensity or the performance of a solar panel. Okay, a solar panel has its efficiency as 20%. Whatever light you will be incidented on solar panel, the 20% will be converted into electrical energy, and rest all the other energy will be converted into heat or losses. Right. So this efficiency, this performance ratio for a solar panel is field factor is 75%, and together if you consider for a solar system, it comes to 73%. So we have optimum energy generation for our own college, whatever this is, what, 200 kilowatt. Okay. So this is all for design point of view. So while designing a project, for designing a plant, we can design it on a total solar rooftop for agriculture. While designing a plant, you have to specifically select a Google map area. You have to select the space where you will design the plant. Let's say this is our helipad. This is a ground of our college. This is staff campus of our college. So this is a 1 BHK room building, and we'll try to install solar panels on this room. Okay, so available area. So whatever we need to do is, you get an area from Google Maps. Okay, you can see all the latitude, longitude. Currently we haven't designed anything on this thing, so on this side you have all this zero. When our design will be completed, and when we'll have, then we can calculate the generation, what will be annual and what will be the performance ratio. On the other hand, we have the undo things. We can have okay, we can have save, and we can export the information and share it with our clients. Right, so this is the car parking area this side, and this is the building which we will try to install solar panels. The next thing we have is model here. So these are all the design tools which will be used. So this is for model, this is for obstructions, this is for solar panel module quantity. By this tool you can calculate the wire size, whatever it is needed. For these things you have all the types of inverters installed, available in the market. So this is the heat access, and this two will show you the solar intensity and heat access. Here you can calculate the dimensions of building. You once have to visit the building, you must have a rough estimate of the length with the length and breadth of the building. Height not so important that much. And you have the views, you can see it into 2D, 3D, and also you have line diagram and various layers for designing a solar system. So basically all these tools, but these tools you see are just less. You see different types of buildings. There are some buildings of flat roof. So this building you see here is a flat roof building. Okay, then you have pitched roof. Pitched roof, you can see the emoji, you have pitch. You have a specific angle which you can change. In terms of our college also, which the design which we have seen earlier. So it has also pitched roof. It has its own pitched angle, right? So draw surface, you have some various types of. This is a simple shed type of thing you can design, and in the draw phase you can specifically design different types of pitched angles. You have various commercial buildings with different types of angles, so you can use this tool and manipulate the pitch angles at different types. And this is a different types of shape building you have, then you can draw it manually. You need not in rectangular or square type of things. So this has a basically flat roof, or you need to know whatever shape the building. Next thing is obstructions. In obstructions, you have polygon, you have rectangle. Rectangle in the sense what you have some extra pillars removed out of the slab roofs, right? So this rectangle, small rectangles, you can draw it here, small, so that you can have an intimate. So when you have a detailed design of your roof system, then you can optimize it to install solar panels, install solar structure, whatever you will be using, so it will use it. Cylindrical systems, you will have air ventilation systems. Some buildings have air ventilation systems, so that systems you can use for to use to design air ventilation systems. So can be there. Some have roof lights installed. So whatever the obstructions you have, basically these types of you can replicate in and design, and it will be various. It will be useful in your design system. Then when designing a solar system, there are important ways. This is a walkway. Walkway is a path where you can walk, which is very useful while doing the maintenance of solar system, while cleaning solar panels, while installing, while getting the defective solar panel out, while checking all the wiring systems. So this is a walkway. You can design a walkway in a solar system. I'll show it in our college design also. The next thing is safety line and handrails. All these are related to safety. Okay, safety line is where you can attach your hinge and have your safety line. Used it very useful for sheds or flat roof structures, where directly solar panels are installed at zero surface, at zero angle on various types of slow shades. Okay, then this is handrail. You can have an handrail design in your system. You have a property line. Property line indicates the your land property, and you cannot exceed your solar system solar design beyond that line. Okay, so it helps you to have a restricted area. It helps in designing solar system in an city type of thing where the property line matters a lot more things. And this option gives us trees, so you can replicate various types of trees in it. And these are different types of trees. You can say you can have a trunk height, you can have its crown height, and different types of trees. You have pineapple, plum, and you can make your design very beautiful to look. And you can have, and you can use it for also shadow analysis. Okay, so all these parameters are very useful for design point of view. Okay, so while moving design point of view. So what we'll do is we'll look all what these three types of roofs look like, so that it will be us in designing a solar system wherever whichever building we have. Let's say this is a rectangular building, or we'll have this. So what I have done is I have selected a model at flat roof. Then I'm selecting just a random corner. You will have length coming up. Okay, so this is a 5.5 meter length. Okay, so you can verify it at its own point. Then you have construction tools where you get to know if your lines are coming straight or not. This is a rough of a roof. This roof I'll take it straight to have a lot more solar access. And this, so this you get a workspace area. This is what you will have to work, and this space you will have to work. Okay, and in this is the available space you will be using for solar. So you can calculate the lengths on both the sides. You can have the depth of all other types of system, other type of architecture, building architecture. Okay, the next thing you will see is you have the model area, which is in square feet. Okay, so you can calculate it with area. Whenever you visit, you have a site survey. The next thing you do is to have the building height. This height currently has it has set up as 3 meters. So you will have to put your building height in meters. So let me put it as 6 meters. Okay, then this is base height, this is top height. So base height, top height defines in various different ways. Represents the building angle, at what angle building, and because we have clear cut installation of roof, so we need to change the angle of building. Then this is carpet height, and this is setback, whatever setback you need. We'll have an update, and then if you go to a 3D view, you will have a flat roof ready for your solar design. So now whatever we have is, this is the depth area like this, so which we have neglected, right? And this is the access roof, right? So now what we will do, we will design this roof access, whatever it is there here. Now we'll go in obstruction, then we'll select it as a rectangle. Okay, then we'll roughly select the area. We'll go into model, we will have a flat roof. And give it a base height as 3 meters. And now if we see in a 3D view, you will have the roof access at 3 meters. Okay, the total height which we have set here is 6 meters, and this is 3 meters. Almost you will see a depth here. Okay, so you can increase this height. I am increasing it to 10 meters. Okay. So this is what a flat roof looks like. Okay. Is it clear? This is basic system, whatever we can do. So next thing we will do is, we will have a pitched roof design over here. While designing a pitch roof, you will have different types of shades. So you can have an approximate length. Okay, so this is what a pitched roof looks like. We'll change its base height. We'll hit update, and then we'll go to 3D view. Okay, this height you can change it. So this will replicate you the same pitch angle, and also you will see its direction, north side up, south side down. So we have this available space for solar installation. So if the roof is not in such a way, then you can design it in other ways also. You can change these distances. You can change these distances and have a more solar access, or whatever the space is, you can calculate it and design your pitched roof in such a way. Okay, so that you have an optimal space or optimal shape available for solar access. So again, when you will go to 3D view, you will have its design. Why I am doing this is you can install a lot more solar panels. You can try various ways. So I'm just manipulating the design. Whatever building type you have, you can design it in such a way. Okay. So then the another thing is you have this is a one side. So this represents industrial, a normal industrial design, or this is a complete flat roof shed. Okay, so this shapes and sizes you can increase the base height, and also you can update the design. Also you can update the design in other ways. Any type of, basically these three types of roof designs you can have it, and also you have to tilt the angle so that it is solar accessible. The tilt angle is almost set for 20 degrees because it is the optimal solar generation angle for our latitude and longitude. So this tilt angle is calculated through our latitude, longitude, whatever it is. So let us see, keep it at 22 degrees. Okay, and then okay. So these are basically three types of roofs which we can have, which we can use it for designing. Okay. A lot more things we need to learn while designing roofs are the actual structures used for this, because if you have several types of obstructions, let's say cylindrical, then you have to select it this way, and then you can see it in a 3D view. Okay, so different types of panels, different types of air vents, different types of obstructions, whatever are there, you can use these things for. Also you can have safety point of view, safety lines used. You can also have handrails. Okay, also you can have a walkway, and also you can have the various types of trees we have seen, right? These are several types of safety line. This is a safety line, this is a handrail, and this is a walkway. This is a walkway. This software has almost machine learning function, so it replicates almost everything. You can modify the walkways in while changing its length, its core height, its width. You can change. Also handrails, you can change its core height. so that it is this height is represented in meters. Okay, and also various things you can do. So basically this represents what type of roofs we are going to design. In obstructions you have different types of obstructions you have seen. The next is module. So module you can see is add a sub array you have. So this is this thing represents the solar installation. Now we will turn on to solar installation. You have the sub array, you have module delete mode and add a table mode. These three options. So we have to select the sub array. We have to give the software available area, whatever available area we have, which you have used. This is the top side of the building. So what we'll do is we'll again select the module area. Okay, so when you select the area, the system calculates the available space and it installs the solar panels directly, directions in mind. Okay, at maximum amount of quantity, maximum amount of solar panels in available space of area. So this is system generated. It is directly designed by the system. The length and breadth of the solar panels is already installed. The system knows whichever solar panels you have. Okay, so while adding an sub array, there will be almost, you will have the summary of total 44 panels. The total DC side, whatever a system has recommended us to install, is 13 kilowatt. Okay, then you will have the solar access and everything being calculated. Okay, so while designing the solar system, what we will have to do is to have a sub array, and then you can change different types of modules. Okay, so this panel, if you see, is of 315 watt. Okay, so here you can have 550 watt panels. You can search various types of solar panels. You have different companies which generate solar panels. So all the data sheets have been uploaded. You can see the data sheet of solar panels here. You have Adani, you have several companies. Okay, so let's click on Adani Solar. This is 550 watt panel. So when you select the 550 watt panel, then there is an option to select if you need to use the bifacial panel. Okay, here you have to select the structure type. Okay, basically flush mount, fixed tilt, and this is the east-west racking. Okay, so we'll go in deep in each point of view later. Then this is azimuth, this is angle at which the solar panels have been installed, clearly north side up, south side down, because this building is not so solar angle friendly. So the angle which solar system has designed is north side up, south side down clearly. Okay. Then you have, now there is no table spacing done. So if you see in our college system, there are specifically tables of 9 panels each. So here you have all these options related to table spacing, the rows you required in the columns, its orientation, whatever you need is landscape, portrait. You have the mount height, okay, where you can install solar panels with almost 4 feet, 5 feet height at different structures. You have vertical spacing and horizontal spacing. Okay, vertical and horizontal spacing is the space in the module, the space in between two panels, which will be horizontally and vertically. Both the things. So now it has been set to auto, and this is row spacing. The distance between these two rows is almost 1 meter. Okay, so then as we have updated the solar panels here, we'll click on update. We'll click on update and these things will be updated again. So why you see is the panel quantity is now less, because the size of the solar panel of a 550 watt panel and the size of 315 watt panel changes. So 550 watt panels is a more length. It is almost 2150 in length. Okay, whereas 315 panel, the size of panels is almost, let's say, 1000 Okay, so this thing it differs. Then you get whatever C is here. As we have increased the wattages of panels, so we have installed less number of panels. This is 33, and DC system what we have is now currently 18 kilowatt installed on solar roof. So when we'll have an installation of inverter, then we'll have both the parameters of DC side and AC side. Okay. While installing, if you want to see it in a 3D view, you can see the different types of structures. Now we have not specifically designed a table, right? So each panel is having its own structure here. This is a simple design, 4-leg structure, what we say. You can have different types of structures in this, and you also have the continuous ongoing summary, DC side, AC side ratio and everything. Okay. So while designing a solar system, we have to design it in such a way that you have to keep in mind where you will install your inverter. So if we consider this type of flat roof in a simple building, 2 or 3 story building, so this is the best place where we can install the inverter. So it will be a waterproof inside this area. Let me see. Here is the entrance, right? So it will be completely waterproof, and you will have a lot more safe. We can connect all these panels. You will have less wire requirement, and we can install it here. So this is the optimum space for connection of inverter. While installing and while designing, we also can change various solar angles also. Okay. If we consider the south facing, then we can change it to 171 degrees and update the design. So then it completely aligns with the available roof angle and available building design. Okay. So this is perfectly set up by the software, and this system, if you see, if this system is almost shadow free. Each panel will have its own solar access. System will specifically have the space required for solar access. That there will be no shadow of this structure coming on the panel, this side and this side. Okay, so this is what you can change different types of angles. You can also you can change the angles from latitude to longitudinal. Okay, portrait to landscape. You can try various structures, you can try various angles, you can try various types of solar panels. Still, you can see if we put the panels in latitude longitudinal side, you will have in number of increase in solar panels, which will go up to 20 kilowatt. Okay, so this is what system is updating. Hello, am I audible? Okay. So you have various shapes and sizes for solar panels. Okay, you can use various shapes. You can use various solar panels and design your system. If you we need to design the solar panel for let's say pitched roof, you'll do the same thing. We will have a module. We will add a sub array. We will give the system the available shape, whichever is there. And the system will directly install a solar panels, a number of panels, whatever you basically the lower wattage which is currently being used in solar is almost 315 watt, or else you can go to 330 watt, 330, 335 watt. So minimum solar panels whichever are being used, so system detects is at minimum. You can change them to whatever size you need to fix, or whatever the maximum wattage if you want to use. Let me see if the software has 720, which Vari has currently introduced. Yes, they have 720 watt panels from several companies. So you can also use this type of panels. You can see the data sheet of the solar panels. It is directly been downloaded now. Okay, you can use various top on companies. Okay, so you can use various types of panels. Then you have different types of, this is a shed type of structure, right? So you can see how the solar system on a shed looks like. These are basically simply stacked on this smooth surface. Okay. Solar structure for shed, solar structure for flat roof. For each thing, the structure, metal structure, it changes. This is the optimum structure which we can have it for solar, for a shed type of thing, this way. So each way you have it. Okay, so one thing is you don't have, you're not having designed this thing. You have not installed walkway. You have not installed railing. So these are the important things which you need to have. You can have a safety line from this point to this point. Also, you can have a walkway. So when you design a walkway, then the available space reduces and the panels get deleted. Okay, so this, let me have the width, let me decrease it. And when we go to 3D view, you will have a handrail in the sense of safety line, which is directly at the lower side, and you have a walkway designed here. So this will be very helpful for maintenance things. So this type of design you can do for a shed type of thing, and then the same thing we have to do, we'll do it for now I am trying to add the subarray again. We have changed the roof angle again. So this is how a shed with a different angle will look like. There is no structure given in it. So what you can do is you can change the structure. Click update, and then we'll go for a 3D view. While designing for a flat roof, you try several designs for a structure point of view. Fixed tilt is okay. We have this type of structure. We will do it portrait. Angle is okay, and update. And if we move to 3D view, this is a 4-leg structure. This is a single leg structure, which is been used for water pumps or at various ways. At parkings also you can see this type of structure. So various types of structures you can try. Also, there is a way where you can have a table structure. Okay, you have to select the subarray, which completely selects all these panels. Then we have to have the number of rows. Let me put it as 3, and columns, let me have it as 4, and update. Then you have the specific 3 rows, 4 columns, and in the available space. Okay, and then you can go to, if you go to the structural angle, you see that you cannot have it as at a single leg, so we need to change the structure for 4 leg structure sub array, and we will change it to got it. The other advancement is if you get the structure weight in kgs, then it will be very useful to design and to procure the material required. You can see the length, you can have the actual whole dimensions, whatever a panel has, and you can see the structure together. And also you will have the total solar generation quantity also. So now this is together, whatever we have created is almost of 72 kilowatt. Okay, total togetherly. And if we delete all these things, then we will have it of single term, right? So do you have any doubts regarding this thing? Yes. Wiring and cabling, you will have it. No, you don't have it in the design this thing, but you have a calculator where you can put the distances of the solar panels and you get the length, total length. Basically, this software, what it does is you give it the specific areas. Okay, you design whatever obstructions you have, and then system decides whatever optimal generation you can do in the regulated space. So what I do, if I delete this panel, I delete these things. I try to add a sub array again. To have a maximum output generation, you have to just select the area. Okay, and then you have to select a sub array, and you have to just change the angle of south facing angle 171 degrees. So this is what optimal solar panels will look like. Then what things comes is how many panels will be connected in series togetherly and form a string. So it depends on, let's say now the system whatever we have designed is almost of 3 kilowatt, 15 kilowatt. Okay, so for 15 kilowatt the rated solar input in voltage and current we have to see, and we have to see the rated voltage of panel. For a 315 watt panel, the rated voltage will be almost 36 volts from per panel. So you have to multiply 36 volts to the rated voltage, whatever input voltage is for inverter, and you have to stack all these panels togetherly to form a table. Let's say whatever I have shown here, a single rows and single columns you can change. Okay, you can change the rows and columns also 2 by 2. Let me know. Okay, so here what you can have access to connect all these 8 panels, let's say 4 up 4 down together, and connect directly the voltage to the inverter. So in various ways you can design the solar panel, you can optimize this thing. And also now what we can do is we can add an inverter. Let me see first what is the DC side. total is 74 kilowatt. Okay, so we have to add an inverter. In inverters also you have various types. You have micro inverters, you have string inverters. So whatever we will be using are string inverters. You will have its minimum kilowatt. Yes, you have 70 kilowatt Solitus. This is also a very nice company. Vari, you all might be knowing. And also what we are currently using is Growat. Okay, this is max KLT. So you have to select the inverter, place it here. Okay. So when you have the inverter, you can have it, you can change its angle, you can change its mount height, various parameters through inverters you can change. By DC string add-on using second knockout. And then MPPT based inverters is yes, they inbuilt MPPTs in currently in this inverter. And then you have to save the design properly. And once the design is saved, then you get an option to calculate the generation. Yes. So already system what it does is for all these solar panels, attached solar panels, we have placed a single inverter here just for a demonstration purpose. Okay. And then what we will have is 104 megawatt of energy annually, and then specific generation if you want you will have it here. Performance ratio you will have it, which is greatly because we are having north south faced solar panels attached properly. The number of solar panels is also more, and also we have less space gone outside here and there. So it is an optimum space. So 76% is the performance ratio. So when you generate and when you save the design, then you get a design summary which you can have and which you can export. When you have a proper design, then you get a proper design summary. So what will be the total generation? Okay, then what will be the solar analysis, loss analysis, global loss incident, shading, soil loss factor, all these losses you will have, whatever percentage they are. Then you have bill of materials, whatever you will have, premium walkway, safety lines, inverter of so kilowatt. So this will be directly a report will be generated. Batteries, where they have considered an on-grid system, so there is no batteries there. And pricing and financing you can add from your point of view. Let's say what you are having it for 34 rupees, then the total estimate cost for 72 kilowatt will be this much. You can have all advanced pricing, discounts and everything, and then you will have the total estimate which you can share it with your customer. Okay, and also you can document your proposal in a way, a proper format. So when you scan, you will have a 3D view of this project. This is almost a 2074 kilowatt. It has happened. This is basic rail, whatever we have added. Okay. And you have a company overview. When you add it, you will have it here. Then this is annual generation performance ratio. A clear-cut report is generated from this software, from this website. Okay. So this is a subscription-based website which has costed us almost 76,000 per year. So recently our subscription has ended. So we can do new projects, but we can edit as many times our old projects whatever we have. Okay, if you have the components, you have expected annual production from your solar plants. You have monthly timetable, what will be the effective DC energy, AC energy, specific generations and performance ratio. So performance ratio, if we study, we have 78% in July. Okay, so this thing is where you have optimum sunlight suitable for solar panel. Solar panel, if you have maximum solar intensity, then what happens is the heat generation is high, and when heat generation is high, you are unable to get the electrical energy at its output. So optimum you have it at 78, and also November you will have optimum generation. You have different types of tilt angles. You have almost solar access and everything. You get all the shadow analysis reports generated by the system. You get the map. This thing we can also do in the design. I'll show it you to tomorrow. Okay. Then production losses you will have, environmental impact, carbon dioxide offsets you will have, then equivalent acre of deforestation you will have, coal burned you will have. All these things you can have with a documented total proposal. You can download it, you can share it, and also you can finance it at a lot more things. So this is a basic overview of the software, how you can design several designs. You can try several types of panels. So tomorrow what we can do, we'll work out a specific building, okay, to its complete start to end thing. Today I have shown you almost small things. Um, mm, small things, all the parameters in almost introductory way. Okay, so tomorrow we can design any of the building in proper start to end way, in a proper way, where you can have your own let's say generation report and a clear cut design, so that it is very helpful. Okay, so I feel that's all for today. If you have any doubts, you can ask. So tomorrow we will have a single building. Let's say this is a 2 megawatt solar plant which we are designing for Garda, Garda Chemicals Limited. Okay, and also we are having one plant for our Garda college also, that I have shown you already. The actual number of panels, the actual number of wires, what you can do is this thing. Okay, so that's all for today. Any doubts regarding the software, any doubts related to solar, any queries related to solar, you can ask. Yes, okay. Yes. So can I leave the meeting? Okay. Thank you. Thank you everyone. Thank you.